Hello, guys. So today, while you are waiting on your teacher to begin, if you will flip to the back of your packet, and there are some pages called Extra Practice. You can work on those at any time whenever you have a down moment. That is something, just extra things for you to work on. So this week, we're continuing our work with UPSC. So if you will turn to the first UPSC page, it's titled Tuesday, Part 1. Here is the first problem. So if you will first take time to read silently, you can pause the video while you read silently. Then we will do a choral read all together. I'm going to go ahead and read it out loud so that you can hear the problem being read. The ratio of boys to girls in Ms. Walker's class is blank to blank. There are blank girls in the class. What is the total number of students in Ms. Walker's class? So what you should do at this point is begin the process of understanding and planning. So remember, when we are understanding a problem, we are looking for important information. We are looking for what the question is asking. We're really just breaking down all the different parts of that problem. When you're planning the problem, you should begin to either plan your steps. You could think about what different processes you could use. At this point, without numbers, it is a little bit harder to do that planning piece, but you can start to get an idea. We see the word ratio. Okay, we might have to set up a proportion. So those are kind of the things that you want to think about when you are planning, is what math processes are we going to use? And again, feel free to pause the video at any time when you need to. So now that we have our actual numbers, the ratio of boys to girls in Ms. Walker's class is 2 to 3. There are 18 girls in the class. What is the total number of students in Ms. Walker's class? So look back at your plan. You can now either estimate your answer using these numbers. You can solve using estimates, then solve using exact numbers. Now in this problem, we don't have any fractions or decimals. We only have whole numbers. So you might not really have to estimate in this situation, but you could use things to solve proportions. You could use scale factor. All right. One of the things with this problem is to make sure that you're finding the total number of students, not just how many boys there are. So that's part of that understanding piece that can kind of determine whether you're getting the correct answer or not. So go ahead and pause the video. All right, so when you're done with that problem, we're going to move on to the second problem. Kira downloaded blank pictures from her cell phone to her computer. These pictures took up blank megabytes on her computer. If each picture takes up the same amount of space, how many megabytes would blank pictures take up? So again, we know that our standard this week, I'm going to go back here, is 7.4D. It deals with ratios, proportions, proportional reasoning. And it looks like we are going to be setting up a proportion. Think about the things that we're understanding here. We're downloading pictures. Each picture is taking up a certain amount of space, and we want to know how many megabytes a certain number of pictures would take up. So you would set up a proportion. We would have pictures and megabytes, set up what you know, set up what you need to know, and then we could cross multiply and divide. That would be the process of a proportion. Now that we have our actual numbers, she downloaded 264 pictures from her cell phone. They take up 528 megabytes on her computer, and each picture takes the same amount of space. How many megabytes would 35 pictures take up? So you could estimate, you could round this number to like 260 or 270. You could round this to 520 or 530. 35 is somewhat of a nice number to work with. You could also round it to 30 or 40. You could round and find your answer, and then you want to solve using exact numbers. Check your work and see if it's reasonable. I know that 264 is about half, and if I actually do the math, it actually is exactly half of that number of megabytes. So if I reduce that, it looks like one picture takes up 2 megabytes. So 35 pictures, how many megabytes would that take up? There's another proportion problem for you. So just make sure when you're done solving that you go back and check your work. You can check for reasonableness. You can check your exact answer against your estimate, see if those are close. All right, thank you guys. I hope you all have a great day.